Hi there everyone and welcome back to the channel. In today's video, we're going to be taking a look at two new flight controller and ESC stacks from Newbeedrone, the Hummingbird 200 RaceSpec and the Hummingbird 305. Both of these stacks feature flight controllers with built-in Express LRS receivers and AM32 ESCs with an 80 amp rating. For the RaceSpec 200, it's on 6S, and for the 305, it's on 8S. In this video, I'm going to be taking you through all of the key specs and features of these ESCs on the bench, and then we're going to be testing the 305 ESC to destruction to see if it really stands up to that 8S 80 amp rating. If at any point during this video you'd like to pick up one of these new stacks for yourself, then I'll put links down in the video description to where you can get yours today. And they are affiliate links, which means that if you click through and make any purchase, I get a small commission from the retailer. It doesn't cost you anything and it helps support the channel. So please do use those affiliate links if you possibly can, and thank you for your support. Let's start with the Hummingbird 200 RaceSpec flight controller. And this is the top of the board, and you can see that we've got a little panel of LEDs over here to show us whether we've got battery voltage, whether the 10 volt regulator for the VTX is working, and whether the 5 volt reg for all the electronics on this board is working. There's also a little red flashing status LED. In terms of direct solder pads, we're really well taken care of on this board. We have direct solder pads for all of the plug connections, and in addition to that, we also have pads for I2C and LED. So if you want to use a GPS with a compass module, or you want to use a addressable LED string, then you can do both of that with this flight controller. Over here are the direct solder pads for an analog camera. And this flight controller is using Newbeedrone's custom OSD chip. So you'll get all of the fancy Newbeedrone graphics using these analog pads. And there are also direct solder pads for the VTX plug. Let me turn the flight controller over so you can see the plugs. This plug is sort of DJI compatible. So you can plug a DJI air unit into this, or an HD0 VTX or another digital air unit, and it will work, but the pin for DJI S-Bus, so if you want to use the DJI controller, in this plug, that pin is actually the VTX output for the analog OSD chip. So you can't use the DJI controller if you just use the plug with the air unit. You're going to need to take the S-Bus wire out of the plug and then solder that onto another UART in order to be able to do that, because Newbeedrone have repurposed the S-Bus pin for analog video out. I actually think this is a pretty good compromise for people who want to use analog and digital. This will work with both of those pretty seamlessly. And with the built-in Express LRS receiver, I don't think you're really going to be using the DJI controller when you have that option. This plug is for the ESC, and the UART2 RX pin is made available for ESC telemetry in this plug. In terms of other UARTs, the first UART, UART1, is internally connected to the Express LRS receiver, so that's not usable apart from for that. UART5 is available for the VTX, so that's in this plug, and UART7 is free to use for a GPS or anything else you want to do. One thing to note about the internal Express LRS receiver is it uses two of these little chip style antennas. So it is a diversity receiver, but I'm not a huge fan of these chip style antennas. Even for racing at close range, if you're using Express LRS at the highest packet rates, so 500 or 1000 Hertz, you do still see some dropped packets with these chip style antennas that you don't see if you're using T-style antennas, because the reception is much better. I would have liked to have seen a UFL connector and a T-style antenna for this flight controller, just so we can get the best possible reception, so that we get no missed packets even at the highest Express LRS packet rates. But I can see the advantage of having a very compact integrated design, so I guess this is personal preference. The flight controller is using the ICM 42688 gyro, and it supports external clock sampling in Betaflight 4.6 if that's a feature that you're interested in. We've got 16 meg of black box storage, and the flight controller is using the AT32F435 chip, which is a newer chip that's being used in flight controllers. It's got more flash memory than the F722, which is good. That gives it more future proofing when Betaflight adds new features that require more code space. And it's got faster performance than an F405, but it is just ever so slightly slower than an F722. And the reason for that is that although the clock speed of this chip is higher, it's using ARM M4 cores rather than the M7 cores that are in the F722. So it's not quite as fast as an F7, even though it's got a higher clock speed. Now let's take a look at the 200 RaceSpec ESC. And this has a typical sort of 5-inch racing layout. So it's a larger form factor, 20 by 20 M3 holes, and it's using full-size FETs. Again, we've got a little LED panel here to show that we've got the 12 volt and 3.3 volt regs working to power the electronics on the ESC. And the solder pads for the motor wires are really nice. They go all the way around the board, very, very easy to solder to and to get a really firm connection. We've got direct solder pads for the connection to the flight controller, but I think everyone's going to use the plug because that's a lot easier. The ESC runs AM32 firmware and it has an 80 amp rating. Newbeedrone say this is a continuous rating. Based on my testing of the larger 305 Hummingbird, I would say that this is a sort of a burst rating for a few seconds, not a continuous rating, because obviously the laws of physics still apply to this ESC. And if you're driving 80 amps through something this size, particularly multiple channels, then there's only so much heat that you're going to be able to generate inside this thing before it gets too hot. And even forced cooling is only going to take you so far, as we'll see later on. We've got a nice pad to solder the capacitor and the XT60 connector, and these pads also go all the way around the board so you can get a nice firm connection. Now let's take a look at the Hummingbird 305 flight controller. And again, we've got a nice panel of LEDs to show us all of the BECs. We've got 2 5-volt BECs on this board and 1 10-volt for the VTX. These LEDs show that they're all working. And the top of the board is dominated by this micro SD card slot for logging. So if you're someone who likes black box logs, then this is a great flight controller for you because you'll be able to put a 4 gigabyte or even bigger micro SD card in here and never have to delete a log ever again. There are direct solder pads for all of the pins, but all of the pins pretty much are on the plugs, so you don't need to worry too much about that. The only pins that are available here that are not on plugs is the TX5, RX5, the I2C pads, and the LED pad. So pretty much everything else that you might need is on a plug. You can see on the top of the board, we also have the 2 antenna connections for the Express LRS receiver. And just to put them side by side, these look like UFLs, but they are not. They're smaller than a UFL connector. Maybe it's an MH4 connector. These connectors, I've had experience with them on other Newbeedrone flight controllers, and they are what I call one and done connectors, which means that you connect them one time and you never take them off, because if you try and take them off, 50% chance you rip the connector from the board and you're just left with a few pads on the board and the whole connector comes away still attached. So these are one and dones. Just connect them and then act like they're soldered on the board and you can't remove them. UFLs are much more forgiving if you want to kind of take them off and put them back on. These are not. Let's turn the board over and have a look at the other side. So here we're using the STM32 F722 flight controller, which is very, very tried and tested, nice and fast. It is a bit more limited on flash storage space than the AT32 F435 that we saw on the 200 RaceSpec, but it's plenty for current Betaflight. We also have a whole bunch of plugs on this flight controller. There's obviously a plug for the ESC. Next to it is a plug for an analog camera, and this flight controller has Newbeedrone's Analog OSD chip on it, so you can do a graphical OSD with an analog camera and video transmitter. We have a plug for an analog VTX, and next to it a plug for a digital VTX. And unlike on the 200 RaceSpec, this digital VTX plug has the S-bus pin connected to RX1, so you can use it for control of the drone. Then we have UART 2 and UART 4, both broken out on plugs to connect to any peripherals that you might want to use. This board features the ICM 42688 gyro and the SPL 06001 barometer, and it supports Betaflight and iNav targets. So at this point, you're probably thinking, as I was, a 30x30 ESC with an 8S 80 amp rating is quite a claim. Does it stand up to test? So I connected this ESC to an AOS Supernova 3220 700 kV, which conveniently pulls 80 amps at full throttle on 8S. And I got my thermal camera on the ESC with some forced cooling, and I did some testing. So let me take you through the test setup that we're going to be using to put this ESC through its paces. We have the Newbeedrone Hummingbird ESC connected to the Taito Robotics Flight Stand 15 Pro, and the ESC is being powered from 8S. In fact, it's being powered from this GNB 8S 3500 milliamp hour LiPo. The ESC is going to be connected to the AOS Supernova 3220. This is the 8S 700 kV version, which I know draws 80 amps on this HQ 10x5x3 prop, so we can test the ESC to its maximum current rating. The Flight Stand 15 Pro is obviously going to be controlling the ESC, and it's also going to be measuring the amount of current that the ESC is drawing using this Hall effect current sense module here, as well as the voltage being applied. During the test, the ESC is going to need some forced cooling, so I have this little USB fan here, and we're going to be using that to keep the ESC nice and cool and give it the type of airflow that we would expect it to see in flight. So with all of that, let's put this ESC to the test. Now let's look at the thermal camera results from these tests. And we're going to start at 20 amps of current as measured by my test stand. And this is with a sort of mild amount of forced cooling. So I have got a fan on the ESC, but the fan's maybe 50 centimeters away, blowing across the ESC. You can see that even at 20 amps, we are drawing 600 watts with the motor, and the board temperature gets up to around 60 degrees, with the FETs on the channel that's being driven hovering around sort of 95 degrees C. And the ESC seemed totally happy at this current level. Now let's look at 40 amps of current. And here I've moved the fan a little bit closer to get the cooling a little bit better across the ESC. Here the motor is drawing 1200 watts, and you can see the board temperature hovering around 50 or 60 degrees, with the FETs on the channel being driven now getting quite warm. They're up at about 115 C. That is not that hot for power MOSFETs, but it does show the need to have cooling. Even here at 40 amps, we're nowhere near the rating, but we're still drawing a significant amount of current, a significant amount of power. You can also see that the capacitor on the ESC is also getting quite hot. So you want to make sure that your capacitor also has sufficient cooling. Once we increase to 60 amps of current, that's where things start to get dicey. I've now got the fan very, very close to the ESC, so we've got kind of ideal forced cooling situation. And the board is hovering around 80, maybe even 90 degrees C, with the power MOSFETs now coming up to 180 degrees. And everything is now getting really quite hot. And after about 27 seconds on this test, the ESC actually shut down and stopped operating. So obviously I hit some kind of thermal limit with this test. Now for the 80 amp test, and here everything got very hot very quickly, even with the best forced cooling that I could manage, getting the fan as close as possible. After just a few seconds, the FETs were up to 200 degrees and one of the motor wires dissoldered itself, and the resulting back EMF spike actually fried that ESC channel. So for 80 amps, the ESC is going to be fine for a few seconds, but it's certainly not a continuous rating. So as you can see, this ESC will absolutely do 8S, and it will absolutely do 80 amps for about 10 seconds, after which everything gets so hot that you run the risk of the motor wires desoldering themselves. So I wouldn't say it's a continuous 80 amp rating, but it's certainly suitable for 80 amps for short bursts. And I would say 20 to 40 amps continuous is absolutely fine. particularly if you've got very, very good cooling on the quad. Obviously, if you've got the ESC shrouded, so that airflow can't get to it very, very easily, then you might run into problems at lower current levels, but hopefully these tests give you an idea of what the laws of physics will allow for an ESC of this size. So taking all this into account, I'd like to give you my thoughts on these new stacks from Newbeedrone, starting with the 200 RaceSpec. I think that the flight controller has all of the features that we would expect on a modern flight controller, and the integration of an Express ELRS receiver is a really nice touch and something that I expect to see on more and more flight controllers going forward. I like that it's got black box. I like the choice of microprocessor for the flight controller. It's got a modern gyro that supports the external clock interrupt, so you can use the new feature in Betaflight 4.6 if you want to. It has a few free UARTs and quite an innovative use of the HD VTX plug to work with both an analog and a digital VTX. So I like that. The one negative, I'm still just not a fan of the chip style antennas for getting really, really good packet consistency. Even at close ranges, when you're running a high ELRS frequency like 500 Hertz or 1000 Hertz, I would still prefer UFL, ideally, antennas with little T elements on them to get the best possible packet consistency with that type of setup. But I do understand that some people may feel that the kind of compact nature of having the chip style antennas is better for them in the way they like to build. If you're not a racer, then missing one packet or two packets doesn't matter. If you are a racer, missing a couple of packets in a row can be noticeable. So that's just something to be aware of. The ESC, 80 amp rating, that's not going to be a continuous rating from my testing, but it will probably do 80 amps for short bursts, no problem. I tested it as hard as I could on 6S and it was absolutely fine, absolutely rock solid on my 6-inch quad. So I think the durability is there. I think the board layout looks really good. I like the strong mountings for all the motor wires, so you can solder them really nice and robustly to the ESC, and the form factor is good, particularly for racing. Coming on to the Hummingbird 305, the feature set on the flight controller is fantastic. You know, we've got great choice of processor, great choice of gyro chip, SD card slot, fantastic for black box logging, so you can just fit as many logs on there as you want. Integrated Express ELRS receiver again, and this time with those T-style antennas. The small comment I would make on that is I wouldn't choose that super tiny surface mount connector for the antennas. Just go with the standard UFL because, as I said, I just find those connectors, if you ever need to get them off, they're just 50% likelihood of ripping straight off the board. So UFL connectors next time, please, Newbeedrone, not these little tiny MH4s or whatever they are. It also means that there are more just antennas available if you need replacements for whatever reason. In terms of all the feature set on the flight controller, you know, double BECs, all of that stuff is just great. What we'd expect on a modern 30x30 flight controller. Lots of plugs, lots of UARTs, all good. The ESC, 80 amp 8S rating, will definitely do 8S, will definitely do 80 amps, but only for a short burst. It's not a continuous rating by any means. And that's just limited by the laws of physics. There's nothing wrong with the ESC, nothing that could be done to make it more robust. It's just you put so much heat into the thing and there's only so much mass it's going to heat up. Really love the fact that you can solder 4 capacitors all the way around the ESC. That will help just avoid your capacitors getting super hot when you're running a lot of load. And I would suggest that if you're going to run anywhere near 80 amps, definitely get 4 big caps on the ESC to make sure that that's all going to be okay. Yeah, really nice to see 3 TVS diodes. Normally, I'm pleased if I can just see 1. To see 3 is fantastic, and that's obviously on the 200 RaceSpec ESC and the 305. So I couldn't ask for more, really. So hopefully that gives you my thoughts on those 2 stacks. If you like the look of them, you want to pick them up, there are affiliate links down in the video description that help support the channel and don't cost you anything, so please use them if you can. Thank you for your support. I hope you enjoyed the video, and until next time, I wish you very, very happy flying.